Hello everyone, welcome to my YouTube channel, the DSA Lab. I hope you all doing great. Today we are going to learn very important algorithm from graph theory called Prim's algorithm. If you're a beginner in data structures and algorithms, don't worry at all. The topic might sound difficult at first, but I promise by the end of this video you will clearly understand what it is, why we use it, and how it works step by step. So relax, grab a notebook if you like, and let's learn together. So our topic today is Prim's algorithm, minimum spanning tree. This algorithm helps us solve a very common type of problem, like how to connect multiple points together using the minimum total cost. This concept is extremely useful not only in exams but also in real-world applications like networking, road systems, and electricity distribution. First, let's understand what Prim's algorithm actually is. Prim's algorithm is a greedy algorithm that is used to find a minimum spanning tree of a weighted graph. In simple words, it helps us connect all nodes in the cheapest possible way. It is considered a fundamental algorithm in computer science, especially in graph theory, and you will often see it in university exams, assignments, and even technical interviews. So learning this properly will really strengthen your DSA foundation. Before jumping into the algorithm, we must clearly understand what a graph is. A graph is made of two things, vertices and edges. Vertices are the points or nodes, and edges are the connections between those points. When each connection has a value or cost attached to it, we call it a weighted graph. This weight could represent distance between cities, cost of laying a cable, or time taken to travel. Prim's algorithm always works on weighted graphs because it compares these costs to find the minimum one. Now let's talk about the main concept, the minimum spanning tree or MST. A spanning tree is a structure that connects all vertices in a graph without creating any cycle. And among all possible spanning trees, the one with the smallest total edge weight is called the minimum spanning tree. So our goal is very clear. Connect all vertices, avoid cycles, and keep the total cost as low as possible. Also, remember one important property. If a graph has n vertices, then its spanning tree will always have exactly n minus 1 edges. Prim's algorithm is designed specially to find this minimum spanning tree efficiently. In real life, this can be used in designing computer networks where we want to connect multiple computers using minimum cable length. It is also used in building road networks, railway tracks, water pipelines, and electricity grids. So basically, whenever we want to connect many locations in the cheapest way, this algorithm becomes very useful. The main idea behind Prim's algorithm is very simple and intuitive. We start from the one node and then we slowly grow our tree by adding one connection at a time. At each step, we choose the cheapest edge that connects our current tree to a new node. Because we always pick the best immediate option, this algorithm is called a greedy algorithm. At this point, you might be thinking, why should I really care about this algorithm? The answer is simple. Graph algorithms are everywhere, from Google Maps finding routes to internet connections to social networks. Many systems depend on efficient graph processing. Prim's algorithm is one of the basic building blocks for understanding these systems. So if you truly want to become good at DSA or software engineering, mastering these concepts is very important. Now let's understand how Prim's algorithm works step by step. First we choose any vertex and mark it as a visited. Then we look at all edges connected to the visited vertices. Among them, we choose the edge with the minimum weight that connects to an unvisited vertex. We add that edge to our tree and mark the new vertex as visited. We repeat this process until all vertices are visited. By the end, the edges we selected from our minimum spanning tree. The most important rule in Prim's algorithm is how we select edges. We always choose the edge with the smallest weight, but that edge must connect a visited node to an unvisited node. This rule automatically prevents cycles and ensures the tree grows correctly. If we violate this rule, the result will not be proper minimum spanning tree. Now let's understand everything using a simple example. Here we have 4 vertices A, B, C and D. Each edge has a weight that represents its cost. We will now apply Prim's algorithm step by step to this graph and see how the minimum spanning tree is formed. From A, the available edges are A to B and A to C. The smallest one is A to B with weight 2, so we select it. Now our tree contains A and B. Next we consider all edges from A and B that go to unvisited vertices. The smallest among them is A to C with weight 3, so we select it. Now our tree contains A, B and C. Finally, we connect vertex D using the smallest edge, which is C to D with weight 1. Now all vertices are connected, so our minimum spanning tree contains edges A to B, A to C and C to D, and the total minimum cost becomes 6. So we have now reached the end of this tutorial on Prim's algorithm. I hope this explanation helped you understand the concept clearly. And if you enjoyed this video or learned something new, please like this video, subscribe to my YouTube channel, the DSA Lab, and share it with your friends who are studying data structures and algorithms. And thank you so much for watching, and I'll see you in the next video.